Great, thank you very much. I typically do clinical research similar to you guys. So I don't talk too much about athletic performance. So I'm really excited to talk to you about this underemphasized, under-researched area today. So everybody loves to watch sports and athletes. And I'm sure some of you are thinking, I'd rather be watching Sunday Night Football, for example. Well, if you watch those athletes, it's clear that all the athletes are looking for competitive advantage. And that's not restricted to elite athletes. If you look at those weekend warriors, they are very competitive too. And they're nasty as well. How do you know? Because I play some of them every week. So if you think about that, it is not surprising that this area of research that we call ergogenic aids is very popular and widespreading. So this is an area that emphasizes any means to enhance athletic performance. So it could be oxygen inhalations, nasal strip, compression sleeves, eye blacks, or sports drinks, or even the Viagra, or the deer penis, believe it or not. There are lots of it. So newer kids in the block is this ischemic conditioning. And if you think about this, okay, it is non-invasive and easy to apply. You don't get busted by anti-doping agencies. So it is actually very good. And if you look at what ischemic preconditioning does, it does increase endothelium function. If so, you can increase blood flow to working muscles, thereby improving athletic performance. And if you look at some of the athletes, close to the end, they're grasping air. So if you can increase resistance to hypoxia or resistance to ischemia, that could also enhance performance. So it makes perfect sense. Before I show you the data, I need to touch upon this thing, okay? So if you look at an Olympic marathon time, so this is a gold medal performance, silver and bronze. So if you look at those time difference, you don't think too much of it. But if you express it as a percent, okay, the gold and the silver is determined by 0.5%, which is 270 yards. So if you look at the 0.5%, you think it's not that much. But if I give you 270 yards, that's a lot. What about gold and bronze? It's only 2.7%. Well, it is 0.7 miles of difference, so it's a huge difference that we are talking about, okay? Why am I telling you this? Because I can see some of you whispering to the person next to you as I show you the data. Hey, look at those bar graphs. It's so small. You know, I can see those, so I'm doing preemptive strike here now, okay? Yeah, exactly. So that's a marathon performance. So look, you remember this Usain Bolt in the Beijing Olympics. He won a 100-meter sprint in a dominating fashion and achieving a world record of 9.69. And if you look at the time here, okay, it's 9.69, and the silver was 9.89, and the difference is only 2%. So we are looking at very small difference here in terms of the athletic performance. And if you look at the gold and the bronze, it's only 2.3%. Okay? So, in the graduate school or in the research settings, we are taught the treatment effect in relation to measurement variabilities. So many of the changes I show you could be within the measurement variabilities. So, if we are wearing the scientist hat, as you listen to my talk and showing your data, probably you're going to have miserable time. But if you wear athlete's hat or the sports fan's hat, you're going to have a good time, all right? So let me show you the data here. So this area is not old, it's pretty new. So the first data was published in 2010. This data came from Netherlands. So what they did, it's similar to clinical applications. They had 3 sets of a pre-ischemic conditioning, 5 minutes each. And they used young, healthy, well-trained subjects here. And after that, they performed graded exercise tests to determine maximum oxygen consumption, or VO2 max. So the data they got is this. With a ischemic preconditioning, VO2 max, or maximum oxygen consumption, increased 3%. Okay? So that's the very first study to show the benefit of ischemic preconditioning on the endurance performance. And this second study performed a very similar setup, But at this time, they measured maximum workload and total exercise time in the graded exercise as well. So as you can see here, if you apply ischemic preconditioning compared to control, you can see improvement in their time. And another interesting thing about this study, okay, is that they decided to put 5 minutes of exercise in addition to ischemic conditioning. So the idea is, if you perform an exercise, it does produce waste product, and you can achieve larger metabolic load, and possibly effect of ischemic conditioning might be greater. But that didn't pan out, and you can see the improvement was there, but I didn't see any additive effect of exercise on this. And interestingly enough, when they measured VO2 max, they didn't find any effect of ischemic conditioning or ischemic conditioning with exercise. Okay, so this is the first performance data. What they did is to do a test 5-kilometer running trial. So it's a little bit over 3 miles. Okay. What they did is to study young, healthy, trained men and performed a ischemic preconditioning similar to the one that I've been telling you. Okay. So the 5K running trial was improved by 2.5% in IPC conditions compared with control. And similar to the one study that I mentioned to you, the VO2 max-wise in the same study, they didn't find any difference between the two. Okay, so the data I have shown you so far is based on the aerobic or endurance type of exercise. What about if you focus on more like a sprint or anaerobic energy performance? What kind of data do you get? Well, this is the first study to address this. They used a 100-meter swimming performance, and they used elite athletes of Canadian national level swimmers. And what they found, before I show you, the one interesting aspect of this, okay, they performed ischemic preconditioning similar to the others I showed you. And between the time trial and an IPC, they had 40 to 45 minutes warm-up period. Yet, they are able to find an improvement in the performance in the ischemic preconditioning group. And the difference was 0.7 seconds or 1%. And you may be thinking, man, that's rubbish. Well, but let me show you this, okay? So if you remember this is also from Beijing Olympics, okay? If you remember, Michael Phelps was competing in 100-meter butterfly, and he was 7th at the halfway mark of 50 meters. And you can see he's really way behind. Even here, you can see this is a touch line right here. And this is Michael Phelps. He's way behind. But he was able to win this by 1/100th of a second. So what kind of difference are you looking at? 0.02%. And if you watch Olympics, you know that there are 8 swimmers in the finals. So 8 finishers are 51.12. What kind of difference are we looking at? 2.5%. So what I said, 1% difference makes huge difference. So that's the reason that people talk about Michael Phelps winning 18 Olympic gold medals. That's a huge deal because we are looking for those tiny, tiny competitive edge to win at competitions. So the latest study that we did is to use Wingate anaerobic power. So we decided to assess anaerobic power in the laboratory settings. So you use this Monarch bicycle that, believe it or not, costs more than a typical bike that Tour de France cyclist actually uses in competition. So it's a very expensive one. So what you have to do is to start cranking up those bikes. And when revolutions per minute reaches 150, this weight that's equivalent to 9% of your weight actually gets dropped, and it applies resistance. And for the 30-second period, we can assess decline in the power output. And based on that, we calculate 3 index. One is peak power output, which happens in the first few seconds. And the second one is average power output, which is area under the curve divided by the minute. And also the fatigue index, which is basically how fast your power is declining in a 30-second period. So the protocol is very similar. You got 5 minutes of a occlusion, then we did 4 sets, and we got a Wingate test here, and we decided to do 4 times. So the idea is, if you look at the football, soccer, ice hockey, most of the sports are done in interval fashions. So we wanted to determine if there is any effect in the second, third, or fourth bout of those tests here. So you can see the typical subject getting IPC treatment here and riding a bike, and after that, we collect a blood and urines. And this particular subject didn't really like the blood draw for some reasons. He's hurting right here. Okay, so here's the data we got. Okay, so the peak power output, the IPC treatment had a 4% improvement in the peak power in the first Wingate test. But when you look at the second, third, and the fourth treatment, it didn't have any effect. And when you look at the average power output, it's a similar deal. Treatment did have an improvement in average power output, but the second, third, and the fourth, there's no effect here. And the fatigue index, it's a similar deal. There's no effect on fatigue index that we can see. So in conclusion, the ischemic preconditioning appears to be an effective ergogenic aid to enhance both anaerobic and aerobic athletic performance. However, the effect of ischemic preconditioning on maximum aerobic fitness remain controversial. This application of ischemic preconditioning to athletes is a promising area that require more investigations. That's all I have. Thank you very much.